Hello everyone, welcome back to the session on Agentic AI. The topic for today is custom agent workflow and planning. So the agenda for the day is to learn about custom workflow, the need of custom workflow, what are the core components involved in custom workflow, and how does agent do planning and types of planning, correct? So these are the things which we intend to cover as of today. So first question is, what are custom agents? So a workflow we know is a set of well defined actions, correct? It's a sequence of actions. So when the workflow is followed by agent, it becomes a custom agent workflow, correct? Now why we say custom? Because we can define our own workflows, correct? So the workflows can include perception, reasoning, planning, tool usage, and action selection. All these things starts from perception and goes all the way till action selection. So using custom workflows, we are able to use rule-based and LLM-based hybrid behavior. Okay. So we get a mixture of both. We can call it an hybrid behavior because it will have few things which are predefined and few things in which customization is possible. Correct. So we use both. The part which is predefined is defined, and the part where we can make changes, that part is made by using LLM. Okay. So that's what hybrid behavior is. So why custom workflows are required? Because it gives a complete control over the agent behavior. As you know, we will have to restrict LLM to think in a particular boundary, because in the world of LLM, possibilities are infinite. So we don't want the LLM to keep on revolving again and again without any particular output, correct? So our aim is to get some output, and that too realistic output. So we want to give control to agent at certain points, and at certain points we want to keep the control in our hand. Okay, so in both these places we get full control over agent behavior. There will be certain sections from where we can get the data which are deterministics, which are fixed, and certain places where the decisions can be autonomously made, correct? And it's a wide used pattern in the industry. So everyone would like to give a response which is matching their particular application need, correct? So for example, if I am making an agentic AI solution, I am making agentic AI solution to solve a particular problem related to my business, related to my domain, related to my customer, correct? Predominantly. So when we make an agentic AI solution, we want that agentic AI solution to make use of LLM and other features, but at the same time also know from where to procure data, correct? For example, if I'm making an agentic AI which will look at whether my booking has happened successfully in a particular train or not, in that agentic AI, I will not go and ask questions related to stock market, correct? So each agentic AI is made, each solution in agentic AI is made with a particular service in mind, correct? So that service, it will be able to serve best only when it makes use of both the patterns, correct? Deterministics and autonomous decisions. So what are the core components of this workflow? So one of the major components is memory. It can be a short-term memory or long-term memory, or it can also be a vector memory. It can be tools like RAG API, database, various environments, correct? It can be policies, you can give instructions, and it can be planner, LLM driven decision maker, correct? So memory we use so that we can store the context, so that when an LLM makes a decision, that decision is driven by the data which we stored in the memory, correct? Now tools, we know we have used tools. I think we studied a lot of tools yesterday and day before. So by now I am sure everyone is quite well aware of how tools work, correct? And how are the different ways of integrating tools with respect to agentic AI. So they also provide an important role. Policies, as we know, we have seen few examples of this where we actually want the LLM to think what type of questions it will get and what type of answers we want, correct? And finally, the planner. So the planner is basically decide which step should be executed first and the sequence of steps, correct? So agent planning decide the next best actions. So LLM evaluates current state, goals, constraints, outputs, action plan or tool invocations, correct? So naturally when an agent plans, it will keep in mind, it will divide everything into steps. Step number 1, I will go and bring data from this tool. Step number 2, I will massage the data. Step number 3, I will pass it to LLM to actually give the data in the format in which I will like. And step number 4 can be calling another API, webhook, or just passing the data to whoever has requested the data, correct? So what are the steps to execute? How the planning can be done is decided by agent planning. Now again, planners in the agentic AI world can be divided into following types. Number 1, reactive planner, which gives immediate response. Deliberate planner. Now in this planner, it will divide your entire plan into multiple steps, and each step will have a reason why that step is created. And hierarchical planner will have high level and low level breakdown, correct? So at high level what it wants to do, and at low level what it wants to do, that breakdown will be there. So there will be a tree like structure which the agent will follow, correct? Okay, so you can see an example of simple planner. Plan steps to achieve. So you see planner, plan steps to achieve the goal. This is the context. We will call anyone and then return the step, correct? So prompt is very much important in this, correct? Because based upon prompt only and context only, the entire plan of action will be made, correct? Yes. So the steps in workflow are like this. First, we gather the context, we generate the plan, we execute the steps, we evaluate the results, and this is repetitive. Okay, so we'll keep on repeating. So gather the context again, generate plan, execute steps, see the results. So the results is as per expectations. If not, iterate again. So it's an iterative process. Till what time we will iterate? We will iterate till the number of repetitions which we agree upon, correct? As I told you, the world of LLM has infinite combinations. So it may try to tune it n number of times, but we don't have to tune it n number of times. We may want to only tune it x number of times, correct? Where x is the number of iterations with which we are fine with. So that's what we will do from workflow execution perspective. So in multi-step, what will happen is naturally we will plan again based upon our goal and the context of data, and we will create the steps, and that steps will be run again and again, correct, till we achieve the given result. Okay, so multi-step. So as we know, the react, which we have already learned. Thought, action, observation, thought. This will keep on repeating till we get the solution of our choice, correct? So some of the important things which we have in custom workflow is input output schema. We can have a tool registry. So tool registry will contain all the tools calls which can be available within our workflow, and the agent can decide which of the tool is necessary to solve the given problem, correct? So we can add a planner function, we can implement cycle loops, add safety and limits. Now safety and limits are very much necessary, else the solution will never come out, correct? It will keep on running n number of times till the solution doesn't come out. Okay. So that's what this is. So visually it's like this. User will contact an agent, agent will plan, it will make use of tools, memory, and finally give the output. I repeat again, user will call an agent, agent will make a plan, it will have tools, it will store it in memory, it can again make use of agent to massage the data in the output, and that can be given back to the user. Okay. So let's see step by step what all the steps in a workflow for a particular example. So first step will be always we will require a LLM, correct? So in our example, as we know, we will make use of LLM, which is Olama. Okay. And we know LLM is the brain of your agent. So whichever model you want to use, that model should be downloaded in Olama, correct? Step number 2 will be a function or a helper function to talk to an LLM. So naturally, it will make use of either REST call or the chat function with the model and message, and will try to receive the message and content, correct? So LLM always returns message and content. Yes. So this is a helper function which can call a LLM basically. Part 3, if you see the code here, is LLM based planner. So naturally, when we want to achieve an objective with a current context, we will ask LLM itself to create steps. What is the best step to achieve this objective, correct? So the planning will happen, as you can see here in the LLM, we are saying system return 3 to 6 short numbered steps. So when you pass this, these steps will be understood. LLM will understand what you want to achieve, what is the best way to achieve, and it will give out the steps, correct? Now these steps can be either stored in a file or it can be stored anywhere and executed, correct? Again, we use LLM only to generate steps because we know in agent LLM is the brain, correct? Yes. The steps should be in such a way that they can be easily automated, correct? So that also applies here. This is followed by tool registry, correct? Tool registry, as I told you, is a basket where we can store all the tools which are available for the workflow to complete. So tools can be as simple as an API call, or it can also look up into some third party systems. Like for example, it can look up into database, it can query a database, it can also look up into Redis and something else, correct? So from agentic AI perspective, tools are something like a function to which if I call, I will get the data. Within that, what implementation we put is up to us, correct? We can put a simple implementation of returning a constant data. We can have a implementation which looks up into an API and gives the response. We can have a implementation which looks up into database and gives the response. Similarly, we can also have an implementation where we look up into Redis cache or Cassandra, NoSQL, anything else and get the data, correct? So basically this tool registry class will be a class which will store all the tools which will be available for use, correct? Yes. And that real tools we will use. So in step number 5, we will add some real tools as per our use case, correct? What all we have to do. As per your use case, we will add tools. Then step number 6 will be workflow execution. So workflow execution means naturally we have created the steps, we have created the tools. So now we want to execute the workflow. So when we execute the workflow, it will start executing all the functions or tools. And after that, finally, whatever result comes, that results will be then massaged again by using LLM before presented back to the user. Correct? And this will keep on repeating. As you know, React loop will keep on repeating the above steps again and again till it achieves a expected behavior. Correct? Yes. So these are the steps which are involved with any custom workflow model. So now let's see an implementation of custom workflow model. So what I will do is I will go and first start the Docker because we require Olama. Let me go and start Docker. Okay, so Docker is starting. We can start Olama. So my Olama server is started. Okay. So now let's go and create an example of planning agent, correct? So let's start with a small example first, and then we can go for a complete big workflow. So this is our first example. Okay, so what I will do is instead of using LangChain because this gives warnings, we can make use of the normal chat, yeah, from chat LangChain Olama. So just copy this, import has changed, that's the only thing I'm changing. Now we know within LangChain prompts we have chat prompt, correct? Now we have to create steps. So to run steps, we can make use of this runnable sequence. You're able to see that's a corresponding implementation which is available within this core runnables. So runnable sequence, and you know we have various parsers available. I am using str output parser which will convert the output which we get from LLM calls to string, and we also make use of langchange.tools. So these are the imports which we made. Okay. So chat Olama, chat prompt template. We know chat prompt template is used to make a call to LLM to generate an input in such a way that it's very easy for LLM to understand. Correct. After this, what we are creating? We are creating a function def check policy which will take a string on a topic, and from a dictionary where we have key as the policies related to which subject like vacation, expense, remote work. Yes. All that information we are storing here in the policies. And here policy dot get, whenever topic comes, that topic we are converting into lowercase. And if whatever is found, we will return. If it's not found, we will say policy for that topic is not in our database. Now here we are getting everything from dictionary, but in real world, this will look up a database. It can look up an API. It can look up Redis. You name any integration, that integration you can do within this code. And we will mark it with @tool. Okay, just to indicate that this function is going to be used in the workflow. Correct. Same way, we also have check employee status. Again, it makes use of name as an input. So here I go and I am maintaining a statuses within which we have the key as name and value as the information about the employee. Correct. So then again we use statuses dot get. If name is there, name we will return. If it's not there, we will say employee not found. Then what I do is we create a tools array within which we have a check policy and check employee status. Both these calls we have. Now, first thing, as you know, chat prompt.template.from message in system, you are given advice on what you expect the LLM to do. Correct? You are an expert planning system. Given a user's complex question, break down into numbered list of sequential necessary steps. Each step must be clear, state which tool should use and exact input arguments, or state NA if no tool is used. Do not execute the plan, just generate the steps. So you are very clearly telling what you are expecting from the LLM. And in the list of available tools, you are given both these tools, check policy and check employee. So this is what we were saying in the custom workflow. We will have certain paths which are fixed and certain paths which can be changed. So these are the part. So if any user of this agentic AI system wants to check policy or check employee status, they can check the boundary of agent is limited only to these two functions, correct? Of course, the result what will come from these two functions can be massaged and given back. Okay. And along with that, as a human, I are given our question, correct? So that's what we have here. Then we have execute plan. So in execute plan, we have a input dictionary. Okay, so what we do is in this input dictionary, we take up the plan. We get all the tools in the tool map. We have a regular expression to check whether the tool name round bracket input, correct? This is how we make a function call. If that is present or not, that's what this regular expression does. So to use regular expression in Python, we have the RE module. So we are using this RE module here. So for I comma line in enumerate plan dot split, we are searching the tool regulation and line strip, correct? If match is found, then we are taking the tool name, we are taking the argument structure, and then we are invoking that function, correct? And whatever result comes, that result we are printing. If there is any error, we print error, correct? So it's very simple. So we check by using regular expression whether the steps contains any function calls. If function calls are present, we will allow them to make function calls, correct? And correspondingly display the results. Agreed? So next what we do is chat template dot from template. We are saying a final synthesizer. Given the original answer, the plan and the execution results, generate a comprehensive final answer. So given the question, original state and tool observations, correct? So we have the original question, plan, tool execution results, and the final answer. So again, using this synthesis, we make use of chat olama, and now we are creating a runnable sequence. If you remember, we had used this earlier also, where we can make use of LangChain sequences. So here we are saying first planning prompt will happen. After that, it will go to olama LLM. Then whatever output comes, that will be a str output parser, and we are going to name this as planning. Same way, runnable lambda. Okay. So similarly, execute plan with config. The question which we have here is what is Alice PTO policy and remain in balance. So it will run this run name and execute it, correct? And whatever results comes, that result again I capture and synthesize. Correct. So this is the entire code. Okay. So we can run this code. Now before running, I have to start Olama. Olama is already started. So we can copy this. Please try everyone. So it's a good code. I will explain the code again. So in our example, we have given two tools. We have represented what the tools are. In the first prompt, which we pass to LLM, we are actually asking it to give a response to a complex question by reviewing whether we can use these APIs or not. Okay. Then what we do is we execute the plan. Plan is in the form of a input dictionary plan. So we capture that. If tools execution is there, we execute the tools by capturing the input and the name of the function. So once you find this tool name, okay, so this match.group will give you the tool name. Match.group2 will give you the arguments. We are divided in the arguments, and finally the tool function will get called. Correct? Yes. Execute the full function, and whatever results come, that results it should. Correct? And finally, we are return in original question is input dictionary. Correct. So if you see the question here, it makes use of the input dictionary question, the original plan, and tool observations. It will show. Again, we are making use of chat prompt dot from template. So question, original plan, and tool observations. Correct. So as you can see, we have created this entire chain where we can execute run in lambda and again capture the output. So finally, we call this full custom workflow dot invoke with question as the so if you say full custom workflow, it will execute these steps. So this workflow here we are controlling what steps to get called. Correct. So let's try running this. We open a command prompt. Let's say CLS. Let's say Python and paste this. So the request will go. Of course, you'll have to wait for 2 minutes. So it's running. Let's run this. So you see it generated steps. You see steps are getting generated. Yes. Everyone able to see that? See, it ran and gave you the output. Okay, so this is the way this example is created. Yes, so the question is, what's Alice PTO policy and remain in balance? When they're searched, correspondingly get the data and return, correct? Alice remain in balance. Is 5 days remaining? You see, it came from here. So in this basic example itself, we learned how to create our own workflow, correct? So we are given the tools, we are given a prompt, we are asking the LLM model itself to create the steps using tools, and we are then executing that to give a response, correct? Hopefully the plain agent call is clear. Yes, so that's how this works. So takeaway from this example is two things: chat prompt, which we already learned, chat runnable sequence, correct? Very important, which you can use to run a sequence, and run lambda, which is used to execute a function, correct? This is what we learned from this planning agent example. First example. Similarly, we can create a full-fledged planning agent example, which is what we will show in demo 2. So the next example will include everything, including tool registry, correct? Both. Everything including tool registry. So you see, first we have Olama, time, login. I'm also login. Okay, and making use of typing. So first I create a model. Model is of type Mistral. Then I create the Olama client object. Now, just like the functions which we saw in our earlier site, same function we are implementing. So if you see def LLM message, and we are saying client.chat messages. Okay, return whatever the LLM returns, that we return back, content.strip. Next, we create a plan step. So in plan step, as I told you, we always require two things: what is your goal and what is your context, correct? So if you see plan steps, if I call this plan step methods in the system prompt, you are saying you are a planning agent, return 3 to 6 short numbered executable steps, and do not add any extra explanation. And in the user prompt, this is the goal which you want, and this is the context which the user has given, correct? And then within text, whatever the user prompt comes, that we pass to LLM, and we show it step by step. You see, split by n. Then we use strip. Strip is to remove unwanted characters, and we will keep on stripping it, correct? And that steps we will show. So that is what this plan steps is doing, correct? So based upon the existing context and what we have to do, it will generate all the steps, correct? We also have tool registry. So we have our own implementation of tool registry. We are storing all the tools. So tools will, when you register something, you will give name and a function. then you can call that function, correct? So def, cell, name, str, arguments, str. Okay, so now in the tool registry, we are registering the name of the tool and the function itself. And in the call, we are checking if the self.tool contains it. If contains, we call it. And if everything is successful, we'll return a success with the result, else we'll return exception, correct? So we create an object of tool registry. Now we also have summarize. So this will summarize into 3-4 lines, whatever results comes. And tool keywords, this will predict the keywords from a given text, correct? So what we do is tool.register, summarize is tool summarize and keywords equals to tool keywords. And then we will execute step by step, correct? So execute step, so step dot strip, this will remove unwanted lines. Then if step starts with call underscore tool, it will call the tool by splitting, correct, the step, and it will call the tool and make the data available, correct? This is what this comes. So in the call tool, in the execute step, we check whether the tool is present, then call the tool, correct, step dot split colon. So tool will come, argument will come, whatever it calls, whatever result comes, that result we will use, correct, through LLM prompt. And we also have React loop, thought, action, and orchestration observation. So here in the messages, we will add this. Just stop when the goal is achieved. And then we will have maximum number of iterations. How many iterations you have to run? These iterations are also passed as an argument. Yes. So how many steps you will have to execute, that you are deciding, correct? See, React loop, maximum iterations are passed as an argument. So here what you are doing, you are following the thought, action, observation loop. You will call the tool and stop when the goal is reached. So here I am executing this for maximum number of iterations. I am giving the input message. I am just checking if everything is good, then we are taking only a part of it, correct? Part of that thought and action and return that. So if done is done in the response from the LLM, then we will say goal achieved. Else we will execute this step and keep on repeating this n number of times. How many number of times? Till the number of times you have put in maximum iterations. So this React loop will keep on running till the maximum value you have put. Then in demo, you are given this text. Goal is summarize the documents and generate keywords. Then we are calling plan steps. We are giving goal context and we are printing the steps. So if summary or keyword is present, we convert that to call tools keywords and then print the corresponding output, correct? You see React loop, run React loop and print the corresponding output, React response. So let's try running this. It will take a couple of minutes to run because it's a big code. So CLS Python, run this code. This will take time because there are multiple LLM calls, as you can see, correct? It's running. See, the execution started. It's running the steps. So let it run. It will take a couple of minutes. So when it runs, it will run and give you the extracted process. It will run 5 times because we are given maximum iterations 5 times, correct? Okay, so while it runs, let me explain the code once again from start. So this code is exactly matching the steps which we told. So step number 1 is set up Olama. Step number 2, create a function which can call LLM. Step number 3, you plan the steps based upon goal and context. You make use of LLM to give you concise number of steps, correct? 3 to 6 short numbered execution steps. And whatever steps you are getting, you try to divide it and append it here. Now, tool registry is a place where we will register all the tools. The aim of tools is to get the data from some data source. So here we have provided a register method which will register the name of the function as well as the function implementation, correct? So if name is not in self.tools, then we will refer an error. Else we will just call that function self.tools name and argument and call in the toast. And then we will have this tool registry which we will use in tool summarize. So if you see, this tool summarize is to summarize using LLM. Tools keyword is to extract keywords. You can see you summarize content concisely in 3-4 lines. Here in tool keywords, you extract 5 important keywords. And in tools.register, we are registering these 2 tools. So if summarize comes, it will go to summarize. Else keywords come, it will go to keywords, the functions which we created, correct? And then execute step, it will take step, it will see whether there is a call to tool there. If there, it will split the given data, the first part of which it will use as tool and second part of it which will use as argument, and then it will call whatever result comes that it will store and pass it to LLM, correct? Now in this React loop function, it will take use of goal, context, and one more thing, maximum iterations, correct? So if you don't pass the value of maximum iterations, it will revolve this n number of times till it achieves a desired result, correct? Yes. And finally, as a demo, we are running this, which is still running. See, React loop has started, loop 1, iteration 1. Like this, it will have to finish 5 iterations, correct? Because we are given the number of iterations as 5, it will have to run the 5 iterations before it gives a response, correct? So this is the way this works. So you see everything they were able to plan and execute. This is the way this works. You see, second iteration has started. So iteration 1, iteration 2, like this, it will go for 5 at the max 5 number of times, but it also prints the results. So if you copy everything, right, you will see, copy the results, something like this comes up when all the 5 iterations run. Show you. Yeah, you see. So it will run 5 times and it will give some results like this. You're able to see, everyone. So an output like this will come. You can see intermediate call tool summarize, call to keywords got called, correct, intermediately, while executing this to get the corresponding code, correct, corresponding plan. This is how customized workflow works. So customized workflow is nothing, using LLM to make the input, using LLM to give the output, and also using LLM to generate the steps. So everything LLM is itself doing, correct. So that's the example which we have used here. So once it runs, you will see the corresponding output, correct. Hopefully that makes sense. So everything what we learned here, we have exactly mapped it in the code. So here, if you remember, we connected to Olama, we made use of an helper function to connect to LLM. We made LLM based planner, plan steps we did, where we gave goal and context. Then we build a tool registry in which we can store all the tools. We'll add the real tools to it. And then we did a workflow execution, correct, to give the results. And then we made use of the React model to keep on executing it till we get the desired result, correct. So this is the flow which we have done. Now, while it runs, these are few best practices. Always try to keep the plans as short as possible, correct. Don't try to keep it very big, because the more bigger the plan, the more difficult it will be for execution, correct. So always try to keep the plan short. Verify the output after each and every step, correct. Yes. Always fix the number of iterations. So it should not happen that it should keep on running infinite time, and log every action, correct. Log every action, correct. So these are the best steps. So by using custom agent workflow, you can know it makes it predictable and very powerful, and it helps us to use or create solutions in a dynamic way, correct. So that's the benefit of using this custom workflow. So while our solution is still running, what we can do is we will also see how, now till now tools means we were either used API or we are used mock tools, correct. So as an example, we also want to see how can we actually connect to a database and get the data from database, correct. So that example also we will try to do today. So yeah, this one, MySQL. So to run this particular example, you will require MySQL. MySQL can be easily installed on Docker. So if you see my Docker, we can pull the image of MySQL. It's very simple to pull. I'll just show you the command. Yes, this is the command. So command is docker run minus name. You can give any name of the container, and you can give the password, root password. And since you will want to connect this from your local machine, you will export the port and you can give the MySQL version, correct. So this is the command which you can run to actually start a MySQL server. Okay. So when you run it, you will have to create a database. Creation of database is very simple. Create database name, and you are creating this Olama chat history table, correct. So in the chat, and you will create a table. I will show you the table. So first let me go inside that. So let me start MySQL. So once we start MySQL, we will go to the container. We'll go to exec. We can connect to MySQL minus u root minus p and say root. Yes. So we can say show databases. It will show us all the databases which is available. Correct. So what this example we are going to do? So in this example, we are going to make use of our database to connect to this MyDB. Okay, so MyDB is our database which we have created. So if you see, we have MyDB. So we have created this. So creation of command is very straightforward. Create database MyDB. Correct. So once you create, you can go inside the DB by saying use MyDB. So we have used here in MyDB. Correct. Now what we can say, show tables. Okay, so we have a customer order table. So select star from customer underscore orders. Okay, so these are some customers which we have, some customer names, some product, some quantity, some status, and something which was created at. Correct. So now what we want is, we want our agentic AI solution to make use of this database. So naturally we will require a connector to database. So within this langchain dot underscore community agents, we have something known as toolkits, and within that toolkits we have create SQL agent. Correct. Yes. So what we are doing here is, we are making use of MySQL user. We are given username, password. Of course, in real world, password will be encrypted. And we are also making use of this LangChain community utilities SQL database. So what this will do is, this SQL database can connect to this database, the DB URL. So in the DB URI, I am given it like this: MySQL connector, username followed by password followed by host, where our MySQL is installed, followed by MySQL DB name. Correct. So using SQL database dot from URI, we are given this URI. Then to chat Olama, I am given the model name, in our case Llama 3, and temperature equals 0. Temperature equals 0 means give only factual information. And then we call this create SQL agent, where we pass the LLM, where we pass the database, where we pass the agent type. Agent type is zero short React description, means give factual information, and verbose. Verbose is for us. So what is the question we have? What is the total quantity of all products ordered by this particular customer? Correct. So this is the user query. Now what we do is, that agent which we created, that agent executor dot invoke, we are invoking the input with the user query. It will go and run, and whatever response it comes, that response we are printing. Correct. So very practical information. You see how can we connect to database. Correct. By using create SQL agent, and use that information to answer the query raised by the user. Okay, so our earlier program is still running. So just close it, as we know what output it gives. Open a new command prompt, say CLS, and then we can copy this, copy path, then come here and say Python. So when we will run this file, it will create a connection to database. You can see successfully initialized connection to the database. This is the query. What is the total quantity of all the products ordered by Charlie Davis? So now it's entering that chain. It will create the query dynamically, will execute the query, and it will give you the output. Correct. So let's wait for a couple of minutes. Yes, it will take a minute. As you know, it runs. See, start by listing the tables. Are you able to see that actions? SQL DB list tables. Yes. Will do. You start seeing. It will show step by step. See, it's firing that query. You're able to see that, everyone? It's trying to access the records, three records from customer table. Yes. It's analyzing the data now. Once it analyzes, it will be able to get the data. See, it's firing the query. It was able to make the query. Of course, this is all running on my local system. That's why you see query creation and all took time. If you run it in a very powerful server, this will all happens within milliseconds, correct? Yes. See, it's showing you the thought also, what it is doing. It's very powerful. Fire, and when the results come, based upon the results, it will give. Correct. So you see, the agent was smart enough to fire the query and see. Query seems perfect. It will run and correspondingly give you the output. So see the power of create SQL agent, correct? Can understand the tables. We didn't mention even which table it is, correct? User query, if you see, it was very straightforward. It said that what is the total quantity of all the products ordered by Charlie Davis. So by just listening to this question, it was able to make a judgment by looking at all our SQL databases and tables. It selected the table, it even generated the query, and it was even able to fire the query, correct? That's the power of this create SQL agent, which is given to us by Langchan community, correct? So I repeat the code again. While it runs, first we make use of SQL database, which will be able to connect from this URL. Then we have this chart Olama, and we have this create SQL agent, in which we have LLM database agent type, and because we put verbose equals true, that's why you are seeing it's given whatever thought process it's running and so on, correct? Yes. And then we went and see what is the total quantity of the products. We make use of the agent executor, and it will execute and correspondingly give you the results, correct? Yes. So that's the way it is. So finally, it will answer the question that there are 8. So this is the way we can make use of SQL agents, correct? Okay, so this is the way this is working. So we can also connect to database and get data by using create SQL agents, correct? Even that facility is available. Not only this, we can also connect to external PDFs. So that feature is also available. Okay. So you see here we make use of a third party library with name PyPDF. So using PyPDF, you can create a PDF. You can also using it, we can also read from a PDF. Correct. So what we are doing here is, again, we are making use of the request module, which we made use yesterday. Now in the request modules, we are going to make use of this Olama API endpoint and the Olama model. So in the read PDF text, we are given a file path. Correct. We are given a file path. So if the file path does not exist, PDF file not found, of course. If it exists, we are reading that and storing the content. Okay. Now here we are just simulating the reading. In real world, you can use any PDF reader. There are many PDF reader libraries which are available. We can use it, correct? Now what we do is, we have a series of instructions. Your expert document analyzer, when stated clearly, we are given clear instructions, correct? Full prompt, whatever user question is, document context which we are given, please provide a concise answer. And in the payload, we give the Olama model, which is Mistral in our case, full prompt, system instruction. We are not doing streaming, so we will wait till the entire result comes. And temperature, which is given 0.2. So very near to factual, correct? And then we make a request.post call with the payload. Whatever response failed, we will give. If response.json comes, whatever response will come, that we will give. If it doesn't, then we will say analysis failed, correct? Now we will create a tool mapping where we are saying read PDF text is read PDF text and Olama Mistral analysis is Olama Mistral analysis, correct? These are the tool mappings. Then finally, we also go for PDF analysis agent, correct? So step number 1 is to read from the PDF file. If the PDF file starts with an error, content starts with an error, we will just halt the flow. Else it will go and answer the, it will make use of the Olama model to answer the user prompt question. It will wait and correspondingly based upon the user question, based upon the source file, it will give the final answer, correct? So here we are creating a quarterly report PDF where we are generating this dummy content, correct? And we created that file and we are calling PDF analysis agent. So just like SQL analysis agent, we created our own PDF analysis agent. Of course, here we are reading from textual file, but you can easily make it read from PDF. So what the question here we are asking, what is the budget set for next quarter and what is the hiring mandate, correct? So based upon the user question and PDF path, it will do analysis. And second question, when is the company holiday party scheduled, correct? And finally, after everything is over, we are removing the file. So again, you can see here, we have created our own custom workflow agent, correct, which can read. We are emulating PDF text file, but nevertheless, we created ours. Only thing we will have to replace is how to read from a PDF, correct? That's it. Remaining everything remains same. So this is how we created our own custom workflow to help us in this, correct? So you see that SQL1 ran and final answer it gave was 8. You're able to see that? Again, it took this much time only because of slowness of my system. Else the results will come up very fast, correct? Everyone with me? So you can see the power of Agentic AI where it can connect. It's a very powerful system. So let's see this PDF AI.pf. So let me copy the path. Let me run it from here. Python. Run it. Olama Mistral analysis. Calling Olama Mistral for analysis. So we did that. So now questions are getting executed. Okay, so it's running. Again, it's based upon our data only. Okay, so we had two questions. You see, both the questions were answered. When is the company holiday party schedule? Quarterly report. You can say based upon the provided context, there is no information about when the company party is scheduled, correct? And if you see, one more question was there before that, so both the questions were answered, correct? Yes. Final agent synthesis complete. Okay, I think one question only we passed. We have to pass one more question. How is the outlook? Something was there, correct? I think that result we did not print. We directly went to the next question. We should have printed that result. We should have printed, yes, which is fine. So you now understand that how this works, correct? How the logic works. That was our synthesis. What is the budget set for? Yeah, you see, the first question also got answered. What is the budget set for the next quarter? You can see the budget set for the next quarter is $1.2 million. By exactly looking at that report, it was able to make that judgment, correct? So, doesn't this look like a custom workflow? We created our own workflow, correct? Based upon our text. So, these are the examples which we wanted to cover today. So, let's recap what all we learned today. So today we started with the need for custom agent workflow. This custom agent workflow need is that whenever we answer a particular question, we should be able to give concise answers based upon the data which we have with the freedom of how we want to answer, correct? So the freedom of what we have to from the actual data gathering and from where we want to answer, we want to control, and how can we sophisticate the answer that we want to give control, correct? So we also want, instead of we planning, how can agent itself plan and generate the steps for execution and completion of the given task, correct? So we give the goal into mind, because every agent is a goal oriented mechanism. If you remember the first day, we learned that agentic AI is goal oriented, correct? So we gave the goal oriented task along with the context. Context is the data which it might require, correct? And we gave the context, and based upon that it has to generate the steps, correct? Yes. And naturally, while generating, for doing all this, it will require tools which are external API. Today we also saw how to connect to database, correct? And corresponding policies, rules or restrictions which we want to enforce, and planner, correct? LLM decision maker. So based upon planning, so how planning, based upon the current state goals and constraints, it will decide the next action and plan the tool invocation, correct? So type of planners, we know reactive planner, deliberate planner, hierarchical planner. So multi-step reasoning. So naturally, how to make this? It's very simple. When you give the prompt to generate the steps, you have to give this type of planners. And naturally, we will gather the context, generate the plan, execute the steps, evaluate the results, iterate, and keep on doing this again and again till the number of iterations which we set are satisfied, correct? So typically it follows the React pattern. Well, we keep on repeating the same thing again and again till we get the answer of our choice. So we will also define tool registry. Tool registry is a central place where all the tools required for the workflow are stored, correct? We also decided on the planner function, how the planner function is decided. One of the important things we have to remember as a part of planner function is we have to give the number of steps, correct? We implemented the cycle loop, safety and limits, correct? So as a stepwise, we first connected to an LLM, we created an helper function, we created a planner. The steps were very concise, 3 to 6 steps, correct? Then we build a tool registry. In tool registry, we will register name and the tool. And then we added some real tools to it. And then we executed the workflow, correct? So we created our code where we will see when an external call is required, we will make that call happen, correct? By using regular expressions. And then we did a React loop where we kept on repeating it again and again till the expected number of iterations are reached or our solution is reached, correct? In any one cases, we will use it. So best practices also be covered, that we should try to keep the plans as short as possible, verify the output after each step, avoid infinite loops, and log every action, correct? And in the final conclusion, we also learned how to connect to a database and make a user query use that database. So you were able to see that by using create SQL agent, we were able to fire that query, get the answer of that query. We were able to see that the agent was smart enough to generate the query, run that query, and give answer to us. Correct. In the same way, we also simulated or emulated, you can say, a reading of PDF file and creating our own PDF agent. Correct. So this is what we covered today. So the topic for tomorrow, let's just see. So the topic. So I think we are nearly done with most of the topics. Now we have to go for hands-on. Yes. So the famous hands-on where we create. In fact, most of the examples we did were completely hands-on, but we will also learn a bit about few tools which are generally used for creating a small UI like type in the OpenAI or LLM or Agentic AI world, and we will try to create applications based upon that. Correct. So this is what we are going to develop. So we are coming to a stage where we can create our own project and use that project. Correct. Hopefully that all makes sense. Thank you everyone for the topic today. So there are couple interview questions which generally come. First interview question is how can we connect to database? So connect to database, you have to make use of create SQL agent, and you have to make use of SQL connector where we can give the username password, and in the agent executor in the database we can pass the database reference. Correct. And using that we will be able to fire the query and give the results. Correct. Second question is how can we control, what is the best practice for storing all the tools? So the best practice for storing all the tools is with the help of tool registry. So using tool registry acts as a central place where all the tools required by the complete agentic AI framework can be registered in one go. Okay, so that serves as a central location, keeping all the tools required for agentic AI call in one place, so that multiple agentic AI applications can reuse this tool registry. Correct. So these are the two famous interview questions which are generally asked. Hopefully we answered that. So looking forward for more practicals in coming up session. Thank you everyone. Have a nice rest of day. Thank you so much.